everyone, this is a quick little extra help video on graphs of rational functions. I have a couple different examples for you, things you want to look for, and then I will show you how to approach one of the problems in Acellus. So a rational function is any function that has a variable in the denominator, and that makes it a rational function. So in this case, we've got the function f of x is equal to x over x minus 2. Now earlier in the year we did talk a little bit about rational functions. We talked not so much about their graphs, but about finding vertical asymptotes, horizontal asymptotes, y-intercepts and x-intercepts. So we're going to bring that all back around and talk about how we can use that information to figure out the graph of the function. Remember, vertical asymptote would just be where the denominator is 0. So if I take my denominator and set it equal to 0 and solve that equation, that will tell me where my vertical asymptote is. For my horizontal asymptote, remember that I am just comparing the degree of the numerator and the degree of the denominator, and there's 3 different scenarios. If the degree of the numerator and the degree of the denominator are the same, then we are taking the coefficients in front as our horizontal asymptote. So the coefficient in front of x is 1, the coefficient in front of x down here is 1, so it's basically 1 over 1, or just 1. So if the degree of the numerator and the denominator is the same, we use the coefficients to determine where our horizontal asymptote is. And you'll see that y equals 1 there. Our x-intercepts, where we cross the x-axis, we cross the x-axis when y is 0, so our point would be something comma 0. Okay? To find the x-intercept when we're dealing with this, all we're doing is taking the numerator. In order for the fraction, the whole fraction to be equal to 0, the numerator has to be equal to 0. So in this case, the numerator is just x. So if I set the numerator equal to 0, I get the x-coordinate of that point that is my x-intercept, and you'll see it on the graph. To find your y-intercept, or where you cross the y-axis, that happens when x is 0, and in this case it happens to be the same as the x-intercept. But to find it, you would just plug 0 in for x, and 0 divided by anything is just 0. So those are the key components that you're looking for when you are trying to determine the equation of the graph. Okay, so those are some of the components you're looking for. Another example would be something like this. Now, if you notice, the denominator is already in factor form for you, which is really helpful. But the first thing we're going to look at are our asymptotes. So we've got 2x over x plus 1 times x minus 2. And so our vertical asymptotes are wherever the denominator is 0. In this case, we have 2 different factors in our denominator, so I'm going to set both of those factors equal to 0 and solve both of those equations. So in this case, I have 2 vertical asymptotes, x equals -1 and x equals 2. Our horizontal asymptote comes from, remember, we're comparing the degree of the numerator over the degree of the denominator. In this case, the degree of my denominator, if I were to FOIL this out, I'd have 2x on the top over x squared plus blah, 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 whatever the rest of it would be. And it doesn't really matter what the rest of it would be. I'm just comparing the highest degree of my numerator with the highest degree of my denominator. Since the degree of my numerator is smaller than the degree of my denominator, since the degree of my numerator is smaller than the degree of my denominator, my horizontal asymptote is automatically at y equals 0. Okay, the degree of the numerator is smaller than the degree of the denominator. So in the first example, the degrees were the same. We took the coefficients. In the second example, the degree of the numerator is smaller than the denominator, or the top is smaller than the bottom, we get y equals 0. We can talk about our intercepts. Remember, our x-intercept is we just take the numerator of that fraction and set it equal to 0 and solve for x. So we would get 0 there. And the y-intercept is basically just finding f of 0, meaning plug 0 in everywhere you have an x. So that would be 2 times 0 over 0 plus 1 times 0 minus 2. And you don't even have to go any farther than looking at the numerator. The numerator is 0. 0 divided by anything is 0. So in both of these cases, again, we have an x and y intercept at 0, 0. And you can get that information from that graph as well. Notice at these asymptotes what's happening. I'm going down, and then I'm going up, and then I'm going down, and then I'm going up. That happens in some of them, but not in all of them. It just, but it usually does. At an asymptote, we usually have one end going up while the other one is going down. Okay, so if you know the one end is going down, you know that the other end will go up at that asymptote. Okay, one more quick example here. If you notice, the degree of the numerator again is is the reverse of what we had before. Here we had the degree of the top was smaller than the bottom. Here we have the degree of the top is larger than the bottom. So let's first deal with our vertical asymptote. Remember, we just take that denominator and set it equal to 0. And we get x is negative 2. Okay, our horizontal asymptote, because the degree of the top is bigger than the bottom, there is no horizontal asymptote. Okay. Again, we can find our intercepts. Our x-intercept would just be taking that numerator and setting that equal to 0. If I factor that, I get x plus 3 and x plus 1. And I get x is equal to negative 3 and x is equal to negative 1. So you'll see here negative 3 and negative 1, those are my x-intercepts. My y-intercepts, remember I just plug 0 in for x. So I have 0 squared plus 4 times 0 plus 3 over 0 plus 2. So that would give me 3 halves. So this would be at 0, 3 halves, and you can see that it's coming up right about there. You'll notice there is no horizontal asymptote. In this previous example, we do have a horizontal asymptote, and even though the middle of the graph crosses that horizontal asymptote only really applies to the far, far, far ends of the graph, so closer to positive infinity and negative infinity. Okay, so it's okay in the middle if it crosses over, it's just what's going on at the ends of the graph. So those are the 4 key components that you're looking for. So let me show you how this applies to the problems in Acellus. So here's one of the problems, and the problem here says, let me make this a little bigger. The problem here says to choose the equation for the graph below. Okay, so a couple of things. I know I have a vertical asymptote, so I'm going to list out what I have. I have a vertical asymptote at x equals x equals negative 4, and I have a horizontal asymptote at y is equal to 2. Okay, so my vertical asymptote comes from setting the denominator equal to 0 and solving it. Okay, so if I look at choice A, if I set that denominator equal to 0 and solve that, x plus 4 would give me x equals negative 4. So I know that's a possibility. Choice B, 4x plus 8, if I set that equal to 0 and solve it, 4x equals negative 8, I get x is negative 2. Well, that's not what I have in my graph as my vertical asymptote, so I know I can eliminate choice B. In letter C, I would get plus 1 or negative 1 in my denominator right there, so I know that's not going to be it. In choice D, I've got, if I solve that, 2x plus 6 is equal to 0. Right, I'd get 2x is negative 6, and I'd get x is negative 3. Well, that's not going to be it. And letter E, I would get x is equal to negative 3 and x is equal to positive 3 as my two vertical asymptotes. So that's not it. So I've eliminated all of my choices except choice A, and that would be my answer. Okay, we can also just confirm that by looking at the horizontal asymptote. If you look at the top and the bottom, right, they're the same degree. They both are to the power of x. So all I'm going to do is look at their coefficients. So I have 2 over 1 or 2, and that's what I got from my horizontal asymptote. So in all of these problems, you want to take a look at the graph and just look at vertical asymptotes, horizontal asymptotes, and see what choices you can eliminate from the graph, and you'll get down to the correct answer. Hope that helped everybody, and we'll catch you next time. Thanks, everyone.